In this video, I'm going to do an example of evaluating our business functions. So this is picking up from the prior problem. We have our cupcakes that we're selling at a farmer's market for $3 per each cupcake. That's our revenue, $3 times the quantity of cupcakes is equal to revenue. And then our cost function is our fixed cost, so we have to pay, or we have a cost of $100 for the tent. That doesn't change based upon how many cupcakes I sell. That's a fixed cost. Then I pay for all my ingredients $1 per each cupcake. So this is times $1 times the quantity of cupcakes is equal to cost. Then our definition for profit is how much money did I take in from revenue in my cash register or in my pocket, and then I have to subtract the costs off. That leaves me profit. That's how much money I have that I can put into my business bank account. All right, and so we've got our profit function here, revenue minus cost. I've got to subtract both pieces of the cost. So I have to distribute that negative sign, minus 100 and then minus 1. And then I combine like terms here. Positive 3Q minus 1Q gives me 2Q minus 100. This is my simplified form. Again, you will be asked to write the profit function in simplified form, meaning that you go through this process and you combine like terms, etc. Okay, so now if I have a particular scenario where I produce and sell 30 cupcakes. So notice I'm saying produce and sell. In the real world, we don't always produce and sell the same amount, but for simplification purposes, we're assuming that I make a number of cupcakes and I sell that entire quantity of cupcakes. So if I produce and sell my quantity of cupcakes, that's my input. Q is my input. So if I want my revenue, I'm going to put 30 in for the quantity, and then I substitute in 30 for the quantity here. So 3 times 30 is equal to $90. So if I wanted to write that as an ordered pair, that would be when I input 30 as my quantity, I get an output or revenue of 90. And so I've actually graphed them here. This is blue. This blue function is my revenue function here. And then this orange function is my cost function. So if I look at this, and this is my quantity here, and then I've got both revenue and cost. So when I sell 30 items, I'm going to come over here to the quantity, and then I'm going to go up to my revenue function. So this point right here is when I sell 30 cupcakes, I have a revenue of $90. That's how I would interpret that as well. All right, so now if I look at my cost, so if I produce and sell 30 cupcakes, I'm going to input 30 for Q. So I have 100 plus $1 per each cupcake, and I have 30 of them. And when I put that in my calculator, I get 130. So this is telling me when I produce and sell 30 cupcakes, my total cost is $130. And if I look here, I see my cost function in orange. So when I produce and sell 30 items, this point up here would be $130. So when I produce and sell 30 items, it costs me $130. It costs me $100 for the tent plus $1 per each cupcake. All right, and we can see here then that there's a gap. My costs are greater than my revenue. So whenever the costs are greater than revenue, I have a loss. Costs greater than revenue, I have a loss. I'm operating in the red. Once my revenue is greater than my costs, then I have a profit. All right, so now let's look at our profit function. We can do this two different ways. Profit is revenue minus cost. So I could just take my revenue of $90 and subtract from it my costs, and I get negative 40. So that tells me that I'm operating at a loss. When I have negative profit, that means I have a loss. So when I produce and sell 30 items, I have a loss of $40. So that's directly just using the output from my revenue and my cost function here. Notice though that I can also input $30 for quantity. Here's my profit function here. P of Q is equal to 2 times Q minus 100. So I can just substitute 30 in there and I get the same answer, right? I get P of 30 is equal to negative 40. Let's write that in function notation. P of 30 is equal to negative 40. All right. So again, that just means that my revenue is less, my cost is greater than my revenue. Let's look at another example here. So if I produce and sell 80 cupcakes, that's my Q, my quantity of cupcakes. It means everywhere I have a Q, I'm going to put 80 in. So my revenue is 3 times 80, that's $240. So when I produce and sell 80 cupcakes, I have a revenue of $240. R of 80 is equal to 240. That's in function notation. This is as an ordered pair. I can actually find it over here. When I produce and sell 80 items, I'm going to come over to my quantity of 80, and I'm going to go all the way up until I hit the graph right here. And if I were to follow that over, that would be the point 80, 240. And if I now want to find out what my costs are, I'm going to substitute 80 into my cost function. Again, here is my cost function here. 100 plus 1 times Q is equal to total cost. So I just substitute 80 in for my cost function, and I get 180. And so when I produce and sell 80 cupcakes, my total cost is $180. $100 for that fixed cost plus $1 for each cupcake gives me $180. So C of 80 is equal to 180. And I can come over here and I can see when I have a quantity of 80 and I hit the cost function, I can see that my revenues are bigger than my costs. So it makes sense that I'm actually operating at a profit now. Okay, so let's actually evaluate the profit function. So profit is revenue minus cost. So I have a quantity of 80. I could take my revenue of 240 and subtract from it my cost of 180. That gives me a profit of $60. And again, that is just the difference here. Here's my revenue. Here's my cost. It's greater, right? It is greater. My revenue is greater than my costs. Now, the other thing I could do is I could directly put Q into my profit function. I can write profit as 2 times Q minus 100. I put in 80 for Q, and I get the same answer. So I have here, when I have produce and sell 80 cupcakes, I have a profit of $60. Okay, so that's P of 80 is equal to 60, and you can translate that into words as well.